The universe is expanding, faster than light. But what lies at the edge? Scientists pointed their telescopes outward and found something they didn't expect. From our small blue world, we pull back, past the moon, past the planets, past the frozen edge of the solar system, into a sea of stars. Galaxies bloom like islands of light, each one a city of suns, all racing outward together. But the farther we look, the stranger it gets. Space thins, structures fade. Darkness grows between the lights, hinting at something vast, patient, and still. Astronomers noticed a patch colder and quieter than the rest. A subtle dip in the oldest light we can measure. It shouldn't be this empty, and yet it is, beckoning us to ask why. The observable universe stretches 46 billion light-years in every direction. Beyond that, we can't see. Not because it doesn't exist, but because light hasn't reached us yet. It's not a wall, it's a horizon. And what's beyond it might be infinite. Star maps become time machines. The redder the light, the older the signal, the farther the source. We stitch these ancient whispers into a 3D atlas of our past, layered by distance and age. At the edge, photons grow tired and thin. What we see becomes a fading memory of brightness, a shoreline where information quietly dissolves into night. Beyond this darkened frontier lies everything we cannot witness yet. Worlds, galaxies, and possibilities hidden by time itself, veiled until light can cross the gulf. Step back far enough and the visible cosmos looks finite, a bubble cut from a larger fabric. Its boundary is not an end, but a limit to our sight. Here, the familiar scaffolding of galaxies blurs into abstractions. We leave maps behind and enter inference, models pointing to regions we can describe but not yet confirm. In 2004, scientists found a strange anomaly in the cosmic microwave background, a massive cold spot, 1.8 billion light-years wide. The cosmic microwave background, afterglow of the Big Bang, should be nearly uniform. Yet one region dips conspicuously blue, colder, quieter, as if something stole energy from the passing light. It's colder than it should be, too cold. Some believe it's a void. Imagine a vast cosmic underdensity, a desert of matter. Fewer galaxies means weaker gravity. Photons climbing out lose a little less energy, arriving cooler than expected. Others say it's something else. But even mapped voids seem too small to explain the chill. Through a telescope, the area looks haunting. Less crowded, less lively, as if a piece of structure went missing. So the mystery lingers. A faint pulse in the dark, repeating a question we cannot ignore. Is this a natural fluctuation or a sign of something deeper? One theory, the cold spot is a bruise. A collision between our universe and another. The multiverse isn't science fiction anymore. Quantum physics, string theory, and inflation models all suggest parallel realities, some touching ours. Some cosmologies imagine parallel domains, pocket universes with their own constants and histories, expanding side by side like bubbles in an endless foam. Quantum rules allow many outcomes to coexist in probability. Inflation takes that uncertainty and stretches it, freezing variations into entire cosmic patches. If strings and higher dimensional membranes underlie reality, our cosmos could be a vibrating sheet among many, each note composing its own physics. Where bubbles touch, energy and geometry could scar the cosmic background. A gentle bruise imprinted long ago might be what we now call the cold spot. If true, the edge of our universe might be a gateway. Picture two expanding realms brushing edges, their fabrics overlapping just enough to leave a cooler thumbprint in our sky, a relic of contact across the unimaginable. If the multiverse is real, our horizon is only local. Beyond it, countless worlds swell and fade, reminding us that our story may be one chapter in a library without end. A few scientists, quietly, believe the cold spot is more than a void. It's a portal, a tear in space-time, a place where physics breaks down. Now turn speculation to its wildest edge. The cold spot is a doorway, a twist of space-time where energy funnels and geometry curls like water down a drain. We can't reach it, not yet. Engineers sketch probes that sail the interstellar dark for millennia, relaying whispers home. We are far from building them, but imagination drafts the blueprint first. But if we could, what would we find? If a craft crossed that threshold, instruments might scream with unfamiliar patterns, fields rotating in impossible ways, particles behaving as if the rulebook had been rewritten. The edge of the universe isn't the end. It's the beginning of questions we're only starting to ask. Subscribe for more mind-expanding facts, and let your curiosity take you further than light ever could. Out there, questions multiply like stars. Tell us what you'd explore first, and together we'll follow the darkness until it answers or opens.